In this video, we're going to learn how to differentiate proper subset and how to use subset notation. Then we're going to attempt to find the number of subsets for a set. In the second part, we're also going to learn how to find intersections, unions, and differences of sets. Finally, we're going to attempt to find the Cartesian product of two sets. Here's an example of 6 problem sets, and for each of the 6 problems, it's a description of one set, whether it's a subset of a second set, or in the case of B, is the first set a proper subset of the second set. So it's really a review of subset notations. Let's look at the first one. In the first set, there are 3 elements, 1, 3, 5. In the second set, there are 4 elements, which includes the 3 we just mentioned, 1, 3, 5, and then an extra 1, 7. So in this case, obviously, the first set is a subset of the second set. So that is a true statement. In the second problem, a set with 2 elements A, B is a proper subset of the set AB. So in other words, the set itself is a proper subset of the set, which obviously is against the definition of proper subset. If you flip back to your notes and look at the definition of proper subset, it should say that all the subsets of a set except the set itself. So in this case, this is a false statement. Number 3, a set of elements x such that x belongs to natural number n and x is greater than 10. So in other words, in this set, it includes 11, 12, 13, 14, 15, and so on and so forth. But it cannot include anything between 1 through 10. And this set should be a proper subset of natural number, and natural number are baby numbers. 1, 2, 3, 4 goes on to on and on and on to infinity. So this is a correct statement. D, a set with 2 elements, 2 and 10, is not a subset of another set, which is 2, 4, 6, 8, 10. Notice that they have these 2 elements from the first set, therefore that is a false statement. E, a set of RST is not a proper subset of a set with TSR. Notice that the 3 elements are exactly the same. The orders are different. That is okay. So these 2 sets are identical. They're a set and the set itself. And we said that the set itself cannot be a proper subset of the set. So this is a true statement. Finally, Lake Erie and Lake Huron is a proper subset of the set of Great Lakes. I forgot the braces there. And this should be a true statement. Make sure you finish, try this one 4 on your own before you proceed with this video. So make sure you pause the video. And here are 4 more examples. State whether they're true or not. These are more or less different ways of challenging your understanding of subset notation. For A, the empty set is a proper subset of the set with 5, 10, 15. Empty set is a subset of all sets and is a proper subset of all sets except a null set itself. So this is a true statement. B, a set with UVWX has 4 elements, is a subset of the set XWU. Now, obviously, this is incorrect because V, let's see, XWU. So V is not included in the second set. So the first set has more elements. It cannot be V, since V is not in the second set, the first set cannot be a subset of the second set. C is a set with 1 element, 0, is a subset of the set of the empty set. and this is false. We've mentioned this multiple times that a null set means there's nothing in there. If you have a 0 in there, then that set has one element. Null set has 0 element. Therefore, the set with a 0 in it cannot be a subset of the null set. Finally, a null set or an empty set is a subset of itself. This is true. Again, pause the video and try this one 5 a try, and then return to this page. This is a summary page of all the examples that we have done. If you look through all the past examples, you will notice that a set with one element has two subsets, itself and the empty set. We've seen that the set with two elements in one of the previous examples, there were 4 subsets. And if a set has 3 elements, there are 8 subsets. So if I lay this out in a table, on top I would write the number of elements in a set. At the bottom, I would say the number of subsets. And you will notice that there is a relationship between the number of elements and the number of subsets. If in a set there is no 0 element, meaning an empty set or a null set, we know that the null set itself is a subset, and that's the only subset. And as we mentioned earlier, when I have one element in a set, I expect to see 2 subsets. When I have 2, I expect to see 4 subsets. When I have 3, I expect to see 8 subsets. Notice that if I keep going, if I have 4 here, what do you think this number would be? In other words, what's the relationship here, right? Notice that if I have to go from 1 to 2 to 4 to 8, I basically notice that this would be 16 here, right? Because this would double 8. And then the next one would be 38 when there are 5 elements in a set. And all of them can be written as 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2 is 4, 2 raised to the power of 3 is 8, 2 raised to the power of 4 is 16, and 2 raised to the power of 5 is 35. So that way you notice the relationship between the blue numbers and that with the red numbers. It ties it nicely. So what can we conclude from here? Finish reading this page and see if you can finish, you can fill in the blanks. Then we can make the conclusion that the number of subsets for a finite set, meaning if a finite set has n elements, notice that the set has to be a finite. It cannot be infinite. If a finite set has n elements, then the set has 2 raised to the power of n, 2 raised to the power of n subsets, and 2 raised to the power of n minus 1 proper subsets, meaning proper subsets is all the subsets minus itself, minus the set itself, right? So that's the definition here. So again, remember that if I have n elements in a finite set, I expect to see 2 raised to the nth power, that many subsets. And the proper subsets is that many 2 raised to the nth power minus 1. And let's do a quick example here. It says that find the number of subsets and proper subsets of the set 1, 3, 5, 7, 9, 11. First of all, let's find out what is my cardinality. I have 1, 2, 3, 4, 5, 6. Since n equals 6, I can use the formula above. 2 raised to the n would be 2 raised to the 6. 2 raised to the 6th power is 64. And that's my number of subsets. And the number of proper subsets would be 64 minus 1. I have 63 proper subsets. So pause the video here. I know there's a lot to comprehend here. Make sure you think through it and try this one, number 6, a try before you proceed. In the next video, we're going to shift gear a little bit, so please make sure that you understand everything that we have been talking about so far.